Hello, ma'am.
Visha ma'am, are you ready?
Yes, ma'am, I'm ready.
Shall we go with the screen share, ma'am?
Okay, ma'am. I'm sharing the screen. Is it okay, ma'am, now? Hello,
yes,
ma'am?
Yes, ma'am. Yes, ma'am.
Okay.
We shall start at 11:40, ma'am.
Okay, okay.
Ma'am, shall we go with slideshow, ma'am?
Okay, okay, ma'am. Okay, ma'am.
Yes, ma'am. Thank you, ma'am.
Once again, I'll go, ma'am. After you will say start, I'll start slideshow.
Okay, ma'am. Okay, ma'am.
Okay, ma'am.
Madhu sir, please let me know through chat box when should I start the class. Ma'am, we don't start video, ma'am. Without video, we shall go, ma'am.
I have not started video, no, ma'am.
Okay, ma'am.
Okay, ma'am.
Is my voice clear, ma'am?
Yes, ma'am. It is clear. Ma'am, when you say next, I'll start. Otherwise, means after completion, shall I start?
Yes, ma'am. I will say next, ma'am.
Okay, okay.
It's 11:39, ma'am. At 11:40, we shall start, ma'am. Ma'am, keep looking chat box, ma'am. If I need to tell anything in between, I shall use chat box, ma'am. Madhu sir, can we start the class? Good morning, dear children. Welcome to the Maths 2B Circles webinar class conducted by the Price Society. Webinar 3, Coordinate Geometry, first chapter in Maths 2B. For revision, let us take what are the contents that we have in Maths 2B, children. In coordinate geometry, the first topic is circles. Next, system of circles. Third chapter, parabola. Fourth chapter, ellipse. And fifth chapter, hyperbola. These are the 5 chapters that we have in coordinate geometry, Maths 2B. And in calculus, the 6th chapter is integration. 7th, definite integrals. And 8th chapter, differential equations. We have already discussed the circles in webinar 1 and webinar 2. And this webinar 3 is meant for IPE revision. So in our circles class 1, we shall discuss definition of the circle, equation of the circle and related problems, necessary and sufficient condition for a general second degree equation to represent a circle and related problems. Some important points that we observe depending upon the types of the equations. Dear children, let us take an horizontal line in the plane. And then a vertical line. We shall observe the point of intersection of these two lines. Let this horizontal line be x-axis and the vertical line be y-axis. And the point of intersection of these two lines be the origin. Now, let us collect the points in the plane which are equidistant from a fixed point. The fixed point is in the middle. Around the middle point, we have so many points which are at a constant distance. The constant distance is represented by the green line. We collect all these points. Then the collection of these points is a circle as shown in the figure. The fixed point in the middle is called the center of the circle. And any point on this path P is chosen. Then the locus of P is circle. And the constant distance, if we represent Cp is equal to R, R is called the radius of the circle. Therefore, a circle is a set of points in a plane such that they are equidistant from a fixed point lying in the plane. The fixed point is called the center, and the distance from center to any point on the circle is called radius of the circle. In the figure, the point C is the center and Cp is its radius. Now, we shall discuss about the equation of the circle, children. Equation of the circle with center CH, K and radius R is x minus h whole square plus y minus k whole square is equal to R square. Let us see how can we derive this equation. Given point, the center of the circle CH, K, and we have to take a point P x, y on the locus, children. Locus is a circle. Therefore, let P x, y be a point on the circle. Look at the figure, the circle. And whose center is CH, K? And on this circle, we have taken a point P. Let Cp is equal to R, children. Cp is radius. Let us denote the radius by small letter r. Because P is point on the locus, P satisfies the geometric condition. Cp is equal to R. Squaring on both sides, we get Cp square is equal to R square. We know CH comma K, Px comma Y. So Cp square is x minus h whole square plus y minus k whole square is equal to R square. And is the equation of the locus of P. That is equation of the circle whose center is h comma k and the radius is R. We shall observe a note, children. Equation of the circle with center h comma k is equal to 0 comma 0 and radius r is, that is instead of h comma k, our coordinates of the center are now origin. Therefore, equation of the circle centered at origin and radius r is x minus 0 whole square plus y minus 0 whole square is equal to r square, which is x square plus y square is equal to r square. Previous slide, please, ma'am. So equation of the circle with center 0, 0 and radius r is x square plus y square equal to r square. And this is called standard form of the circle. X square plus y square is equal to r square is the equation of the circle whose center is 0, 0 and origin is r. Next slide, please, ma'am. We shall observe another note, children. On expanding the equation x minus h whole square plus y minus k whole square is equal to r square using a minus b whole square, we shall get x square plus h square minus 2hx plus y square minus k square minus 2ky minus r square equal to 0. And rearranging the terms in the order of the second degree equation, general second degree equation, we shall get x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square is equal to 0. Let us take this as equation 1. Now, let us substitute g is equal to minus h, f is equal to minus k, and c is equal to h square plus k square minus r square in the above equation. What shall we get, children? We get the general equation of the circle as x square plus y square plus 2gx plus 2fy plus c is equal to 0. Center of this circle is minus g comma minus f and radius is under root of g square plus f square minus c. Here the center is half of the x coefficient with a negative sign and half of the y coefficient with negative sign. These two are the coordinates of the center. And radius is rho g square plus f square minus c. And the value inside the square root is g square plus f square minus c must be greater than or equal to 0 because it is inside the root. There should not be a negative value inside the root as far as the real number is concerned. Let us compare the two circle equations we have learned so far. The first form is the circle whose center is h comma k, and in the second form the center is minus g comma minus f. And the first form is called standard form of the circle, and the second form after expansion it is called general form of the circle. Equation in the standard form circle is x minus h whole square plus y minus k whole square is equal to r square. So we shall use this form when you know the center h comma k and radius r. Next, when shall we use the general form of the circle? When we know g, f, c values. See the general equation of the circle, x square plus y square plus 2gx plus 2fy plus c equal to 0. So when you know g, f, c, we shall use general form. When you know h comma k, and the radius we shall use the standard form. In standard form, the center is h comma k, and in the general form, the center is minus j comma minus f. And in the standard form, radius is r, and in the general form, radius is under root of g square plus f square minus c. Is this clear, children? Now we shall observe a problem and the concept we have discussed. Find the equation of the circle with center 2 comma minus 3 and radius 4. So we know the center and radius. We shall use the standard form of the circle. Solution. Let us take a circle, children. Mark the center, mark the radius, C2 comma minus 3, and radius is equal to 4. Now we shall find the equation of the circle that we have drawn here. First, let us write what are given. In solution, first we have to write what is given in the question. Read the data and first write the given values. Center CH comma K is equal to 2 comma minus 3 and radius R is equal to 4. And equation of the circle is, we have to write the formula, children. I have forgot to write the formula here in PPT. Please write the formula. So whenever you write the given data formula and draw the diagram, it gives a good impression for the examiner when they are valuing your answer sheet. So equation of the required circle will be x minus 2 whole square plus y plus 3 whole square equal to 4 square. Within brackets, since you can write x minus h whole square plus y minus k whole square equal to r square. On expansion, we'll get the answer, and this will also be our answer. So x square, and expanding the left-hand side and rearranging the terms in the order of second degree general equation, we shall get the equation of the circle as x square plus y square minus 4x plus 6y minus 3 equal to 0, and is the required equation of the circle. Is this clear, children? In exercise 1A, we have the same problems. So that will be your assignment. Next, we shall discuss the problem 2, children. Find the equation of the circle passing through the origin and having the center at minus 4 comma minus 3. In the previous problem, we were given the radius directly, children. But here, we are not given the radius directly, but there is a condition through which we can get the radius. We shall draw the diagram for this question, children. First, observe what is given. We need to find the equation of the circle. Which circle? The circle passing through origin. So origin is a point on the circle. And what is the center of the circle, children? Minus 4 comma minus 3. So the radius is the distance between C and O. C is the center, O is the origin. So if we find the distance OC, we will get the radius. Is that clear, children? We already know the sentence, hence we can find the equation of the circle. Solution. Given that center of the circle C is equal to minus 4 comma minus 3. Circle is passing through the origin O0 comma 0. Therefore, radius R is equal to OC. Because OC is a distance under root of x2 minus x1 whole square plus y2 minus y square, we shall square on both sides. R square is equal to OC square, which shall be R square is equal to 0 plus 4 whole square plus 0 plus 3 whole square. That is 16 plus 9, 25. R square is equal to 25. Therefore, equation of the circle is, we shall write the formula, children. X minus h whole square plus y minus k whole square is equal to r square. Substituting the values, x plus 4 whole square plus y plus 3 whole square is equal to 25. On expanding and rearranging the terms, we shall get the equation of the required circle as x square plus y square plus 8x plus 6y is equal to 0. Observe the equation, children. The equation is free from the constant, which ensures that the circle x square plus y square plus 8x plus 6y equal to 0 is passing through origin. So for any curve, maybe straight line, maybe the circle or parabola, or any curve which passes through origin will be free from constant in its equation. Is this clear, children? Yeah. Let us observe the statement of a theorem, children. Very, very important. Let us revise. The general second degree equation is, what is the general form of the second degree equation, children? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Where a, h, g, p, f, c are real numbers, real coefficients and real constants. And this equation represents a circle if and only if it must follow certain conditions. Only then the above equation represents a circle. What are the conditions, children? A equal to B, but both should not be equal to 0. What is A? The coefficient of x square. What is B, children? Coefficient of y square. That means x square coefficient must be equal to y square coefficient, but both should not be equal to 0 at a time. Second condition, h is equal to 0. What is h, children? Coefficient of xy. 2h xy term we have in the equation. Second term. Okay. Xy coefficient is h. That must be 0. And g square plus f square minus ac must be greater than or equal to 0. Not 1, children. I'm sorry. That's a mistake. 1 should not be there. It's only g square plus f square minus ac. In this condition, what shall be the center of the circle? Minus g by a and comma minus f by a. And radius is under root of g square plus f square minus ac whole divided by a. Now we shall discuss a problem on this concept, children. Find the values of a comma b if the equation ax square plus bxy plus 3y square minus 5x plus 2y minus 3 equal to 0 represents a circle. Look at the question, children. We have a second degree equation and it is representing a circle. We already know the conditions required for a second degree equation to represent a circle. Using those conditions, we shall find the values of a comma b. Solution. If the given equation represents a circle, coefficient of x square must be equal to coefficient of y square. And the coefficient of xy is equal to 0. Implies coefficient of x square is a and coefficient of y square is 3. Therefore, a is equal to 3. And coefficient of xy is equal to 0. Therefore, b is equal to 0. A equal to 3 and b equal to 0. Now, we shall substitute these values of a comma b in the given equation. We shall get 3x square. No, we don't have xy term because h is 0. Plus 3y square minus 5x plus 2y minus 3 equal to 0. And we shall divide the above equation by 3. Then we shall get x square plus y square minus 5 by 3x plus 2 by 3 times y minus 1 equal to 0. Let us compare this equation with the standard form, general form of the circle. Then g is equal to minus 5 by 6, f is equal to 1 by 3, and c equal to minus 1. Now, radius of the circle is equal to under root of g square plus f square minus c is equal to under root of minus 5 by 6 whole square plus 1 by 3 whole square minus 1. On simplification of which radius r is equal to root 65 by 6. Now we have another important question. If x square plus y square minus 4x plus 6y plus c equal to 0, if this equation represents a circle with radius 6, then find the value of c. Where is c, children? In the given equation, it's a constant. To find out that c, what is the condition given in the question? The radius of the circle is provided. Okay. First write the given things, the given equation and radius 6. Draw the diagram if you can. And compare that with the standard form. Note the values of G, F, C. Write the formula for the radius, children. Root of G square plus F square minus C. And that value is given to be 6. Therefore, substituting the values of G, comma, F, we shall get under root of 4 plus 9 minus C. G is 2, so it's a square. F is 3, it's a square, and minus C. So, in order to remove the square root, we shall square on both sides. And on simplification, 13 minus C is equal to 36 and C equal to minus 23. Is this clear, children? Yes. Now we shall observe some important points, children. If G square, we have discussed that G square plus F square minus AC must be greater than or equal to 0. So that it represents a circle, one of the conditions for the circle. Now so there are two conditions. One is G square plus F square minus C must be greater than, and other is equal to 0. What happens when G square plus F square minus C is equal to 0? That is radius is equal to 0. Then the circle, the related circle, x square plus y square plus 2gx plus 2fy plus c equal to 0 represents a point circle. So the circle whose radius is equal to 0 is called a point circle. And in this case, the center itself is the point. Okay, the center itself is a point circle. Minus G minus F is the only point on that locus, and it itself is a point circle. Is that clear, children? The point circle is nothing but a point or a circle whose center is a point and radius is 0. The equation of a point circle having the center at the origin. If center of the circle is 0, 0 and radius is also 0, 0, the radius r is equal to 0, then its equation is x square plus y square is equal to 0 square, which will be x square plus y square equal to 0. Now we shall discuss another important point. The equation of the circle passing through 0, 0 will be in the form x square plus y square plus 2gx plus 2fy plus c through 0 actually. But c will be 0 as it is passing through 0, 0. Therefore, its equation will be of the form x square plus y square plus 2gx plus 2fy equal to 0. So there is no constant in the equation of the circle when it passes through origin. Let us observe the diagram, children. Let us take the coordinate axis, x-axis and y-axis. Look at the four circles. They are passing through origin. The circles need not necessarily be in this condition. It can be small, more. There exist infinite number of the circles. I have taken just four important, just four circles which can take that form. So since 0, 0 is a point on the circle, Now we have the equation is x square plus y square plus 2gx plus 2fy equal to 0. Let us take another important point, children. Now we are going to talk about equation of the circle whose center lies on x-axis. Let us take the coordinate axis, children. A horizontal line x-axis and the vertical line y-axis. Now, the point of intersection is origin. Now, we shall have a circle. Observe the center, children. Isn't it on horizontal line? Yes. So we shall now we shall see the general form of a equation of the circle whose center is on x-axis. The center is on x-axis, therefore the coordinates of the center will be of the form x comma 0. That is minus d comma 0 if it is minus g minus f form. H comma 0 if it is h comma k form. So there will be only x coordinate will be present. Let us see the general form of the circle whose center is on x-axis. Equation of the circle whose center is on x-axis will be of the form x square plus y square plus 2gx plus c equal to 0. Here I would like to remind you an important point, children. If the same circle passes through origin, that is, the center is on x-axis as well as passing through origin, then it takes again the short form x square plus y square plus 2gx is equal to 0. Is this clear? Yes. Now we shall go with another equation of the circle where the center lies on y-axis. Equation of the circle whose center lies on y-axis. Let us take the coordinate axis, children. And point of intersection of the coordinate axis is O0, 0. And look at the circle, children. Now the center is on y-axis. Therefore, it takes the form, the coordinates of the center takes form 0, y coordinate. Equation of the circle whose center lies on y-axis will be of the form x square plus y square plus 2fy plus c equal to 0. Since x coordinate of the center of the circle, that is minus j is 0, we don't have x term. Dear children, if the same circle passes through origin, the short form will be x square plus y square plus 2fy equal to 0. Now, let us take another definition, children. Two or more circles are said to be concentric if their centers are same. Let us observe the ripples formed in the bucket or in a pool when the still water is disturbed by a stone, children. What you observe? Concentric circles. So, the point at which the stone is dropped will become the center of the circles, and the ripples form in the shape of the circles are concentric circles. Observe the figures, children. There are many circles, but the center is same. As we move away from the center of the circle, the radius go on increase. O is the center of these circles, and R1 is the radius of the first circle, and R2 is the radius of the second circle, and R3 is the radius of the third circle, and R4 is the radius of the fourth circles. So radius is going on increasing, but the center remains same. And such kind of circles are called the concentric circles. The equation of a circle concentric with the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 will be in the form of x square plus y square plus 2gx plus 2fy plus k equal to 0, where k is any constant. That means the family of the concentric circles, the equation of the family of the concentric circles is differ only by constant, like same concept that we have discussed in our parallel lines in the straight lines. The family of the straight line, the family of the parallel straight lines represent a unique equation, and for varying values of the constant, we get varying lines in the family. Similarly, if you go on giving the different values for the constant in this equation, the standard equation, we shall get the circles. Okay. Now we shall discuss the definition of the unit circle. If the radius of the circle is 1, then it is called a unit circle. Any circle, whatever may be the center, if the radius is 1, such circles are called unit circles, children. So the general form of the unit circle, could you guess me? Could you guess the equation? X minus h whole square plus y minus k whole square is equal to 1 square. Next slide, please, ma'am. It's a time for the homework. Dear children, find the equations of the circle with center C and radius R, where C is equal to minus 1 comma 2 and R is equal to 5. C is equal to minus A comma minus B and R is equal to under root of A square minus B square. The condition is provided mod A is greater than mod B, which ensures that the value inside the root is greater than 0. Third one, C is equal to cos alpha comma sin alpha and radius R equal to 1. So this would be our unit circle, children. C is equal to A comma minus B and R is equal to A plus B. Fifth question, C is equal to minus 7 comma minus 3 and R is equal to 4. Solve these questions as your homework, children. We shall move to another important point. We shall find the equation of the circle in different circumstances, children. These are the important concepts. After this, we shall move to another important point. Next slide, please, ma'am. From PowerPoint 2. Hello. Ma'am, we shall go with another slide, please.
Ma'am, equation of a circle is another one.
Yes, ma'am.
Start.
We shall go with the second one. Second PPT, ma'am. It's not shown, ma'am. Yeah. Dear children, we shall discuss equation of a circle when endpoints of the diameter are given. So far, we have discussed the equation of the circle when we know the center and radius, or when we know the coefficients D, F, C in the general form. Now we shall find the equation of the circle when endpoints of the diameter are given. Suppose A x1 y1 and B x2 y2 are the extremities of the diameter of the circle. Then its equation is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Let us prove how we shall get this equation. Let us take a circle and the center. Look at the diagram, children. And we have a diameter passing through the center of the circle. And extremities are marked by capital A x1 y1 and B x2 comma y2. And center of the circle can be obtained by the midpoint of A comma B. So we know the center, and the distance AC or BC can be given as radius of the circle. Therefore, A x1 y1 and B x2 y2 are the 2 points, and C be the center of the circle. Let Px comma y be any point on the circle other than A and B. Now, observe the diagram, children. We have A, x1, y1, B, x2, comma, y2, and C is the center of the circle. And C will be the midpoint of A, comma, B. And Px, comma, y is any other point on the circle. Join AB, children. Join AP and PB. As the diameter subtends a right angle in a semicircle, the angle subtended by the diameter in a semicircle is 90 degrees. Angle APB is 90 degrees. The lines AP and BP are perpendicular. Therefore, slope of AP into slope of PB is equal to -1. You know 2 points, AX1, Y1 and PX, comma, Y. So we can find the slope using formula y2 minus y1 by x2 minus x1. So y minus y1 by x minus x1 into y minus y2 by x minus x2 is equal to -1. Numerator multiplied with the numerator and denominator multiplied with the denominator. And the denominator is sent to other side with respect to division, then it will be multiplication, and transposing the right hand side term to the left hand side with respect to addition and rearranging the terms, we shall get x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0 is the equation of the circle whose extremities of the diameter are ax1 y1 and bx2 y2. And let this be equation 1, children. Also, clearly A and B satisfies this equation 1. A is x1, y1, children. B is x2, comma, y2. If we substitute that in the equation 1, we shall get 0. Therefore, any point Px, comma, y on the circle satisfies the equation 1. Conversely, if a point B satisfies the equation 1, then it satisfies the geometric condition angle APB is equal to 90 degrees. Therefore, P lies on the circle. So, any equation is said to be equation of a locus if it satisfies both necessary and sufficient conditions. Since it satisfied both the condition, the equation 1 is the required equation of the circle. What is the equation, children? X minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Let us observe a problem depending upon this concept. Find the equation of the circle whose extremities are 1, 2 and 4, 6. Dear children, let us draw a diagram. Draw a circle. Mark the extremities of the diameter A1, 2 and B4, 6. From which we shall get, let the given points A1, 2 is equal to x1, y1 and bx2, y2 is equal to 4, 6. Equation of the circle is x minus whose extremities of the diameter are x1, y1 and x2, y2 is, write the formula x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Then x minus 1 into x minus 4 plus y minus 2 into y minus 6 equal to 0. Multiplying and rearranging the terms, x square plus y square minus 5x minus 8y plus 16 equal to 0 is the required equation of the circle. If in any case, if you have forgot the formula, you can still find the equation of the circle by finding the midpoint of AB, children. 1 plus 4 by 2, that is 5 by 2, and 6 plus 2 by 2, 8 by 2, 4. So 5 by 2, 4 will be the center. Let it be C. Then AC gives radius. So you know the center and radius. Then find the equation of the circle using x minus h whole square plus y minus k whole square is equal to r square is the alternate method. Next slide, ma'am. Now we shall discuss the parametric equations of the circle. Dear children, in this revision classes, we shall Take the definition of the parametric equation of the circle now. Statement. The parametric equation of the circle with center h comma k and radius r, which is greater than 0, are given by x is equal to h plus r cos theta, comma y is equal to k plus r sin theta, where 0 less than or equal to theta less than 2 pi. Dear children, h comma k is the center and r is the radius of the circle. And for varying values of theta, we shall get unique pair x comma y, and locus of this x comma y will be the circle again, where the range of this parameter is 0 less than or equal to theta less than 2 pi. So if theta is taken from 0 to 2 pi and substituted in the x is equal to h plus r cos theta and y equal to k plus r sin theta, we shall get an ordered pair x comma y, and locus of this is a circle. Such form is called parametric equation of the circle. Here theta is a parameter. Observe the figure, children. We have a x-axis, y-axis, and origin. Suppose, sorry, it is not x-axis, y-axis. We have a horizontal line and a vertical line and the point of intersection. Let us take that as a center of the circle. And look at the circle, children. We have a point px comma y and CP angle PCX is theta. This is our parameter. For different angles, for different values of this angle theta, we get the different points of px comma y of the circle. And if we trace, we shall get that circle. If the center of the circle is origin, O0, 0, then the parametric equation of the circle having radius r is, actually the parametric equation said x is equal to h plus r cos theta, children. But h is 0 here, so it is r cos theta. And y is equal to k plus r sin theta. K is also 0, therefore y equal to r sin theta, where 0 less than or equal to theta. R cos theta, comma r sin theta are the parametric equations of the circle. We shall discuss a problem on this, children. Obtain the parametric equations of the circle x square plus y square equal to 1. Compare this with the standard form and note the center and radius of the circle, children. The center of the circle is origin. And we have P, r cos theta, comma r sin theta as a parametric values, but r is equal to 1. Therefore, P is cos theta, comma sin theta. X is equal to h plus r cos theta, y equal to k plus r sin theta. H comma k is 0, 0. The center of the circle is 0, 0. And r is equal to 1. Substituting in the formula, we should get the parametric equations of the circle as x is equal to 1 into cos theta, and y is equal to 1 into sin theta, where 0 less than or equal to theta less than 2 pi. That condition must be written, children. The range of theta should be mentioned. Note that every point on this circle can be expressed as, within brackets, that is coordinate form, cos theta, comma sin theta. So for varying values of theta, we shall get a point. Now, obtain the parametric equation of the circle represented by x square plus y square plus 6x plus 8y minus 96 is equal to 0. Draw the diagram, children. Mark the center by reading from the equation. Let px comma y be a point on the circle. And we shall also find the radius of the circle r. When you know h comma k and r, we shall write the parametric equations. Let us write the given equation, children. Note the center and radius. The center of the circle is minus g comma minus f, which will be h comma k equal to minus 3 comma 4. Half of the x coefficient with minus n, half of the y coefficient with minus n. Radius r is equal to formula root g square plus f square minus c is equal to under root of 3 square 9, 4 square 16, minus of minus 96 plus 96. So 9 plus 16, 25 plus 96. So r is equal to under root of 121, which implies r equal to 11. Now, the parametric equation of the circle are x is equal to minus 3 plus r cos theta, r is 11 children, and y is equal to minus 4 plus 11 sin theta. I'm sorry, it's only sin theta written here. It's a mistake in editing. Minus 4 plus 11 sin theta, where 0 less than or equal to theta less than 2 pi. These are the parametric equations of the given circle, children. With this, we shall finish our today's class, children, and let us discuss the problems related to general equation of the circle when 3 points on it are given, when 4 points on it are given, how to prove that given points are concyclic, and how shall we find the value of C if the given points are concyclic, given 4 points are concyclic, are the concepts that we are going to discuss tomorrow. Have a great day, children. Stay home, stay safe.